So my last video was going just a little bit too long, so I decided to cut it off. So let's go back and talk about marginals. Marginal profit is the first derivative of the profit function. Marginal revenue is the first derivative of the revenue function, and marginal cost is the first derivative of the cost function. Revenue function, cost function, profit function. Hopefully I said that right. Profit derived from selling X units of an alarm clock is given by this profit function. We want to find the marginal profit for a production level of 50 units. So I'll explain what this means. Let's figure out what it is, and then when we label our answer, hopefully it'll make sense to what marginal profit is. So the profit derived from selling X units. So you put an X in and you're going to get your profit out. For production level of 50 units. So marginal profit means your first derivative. So we're looking at dp dx. So I'm going to go to my profit function and I'm going to find the first derivative. So the derivative of profit is 3 times 0.0002, which would be 0.0006 x squared plus 10. Now I'm going to take this 50, x equals 50 here, and I'm going to put that in for x. So I've got 0.0006 and then 50 squared plus 10. And when I put that into my calculator and I multiply 50 by itself, multiply it by 0.0006, then add 10, I get $11.50. Now remember, your change in profit is money and your change in X is units. So $11.50 per unit. That's the profit per unit at 50 units. Compare this with the actual gain in profit obtained by increasing the production level from 50 to 51. So now we have to find the actual gain. So now we're saying put a 50 in, put a 51 in. When you put a 50 in and you put a 51 in, well, when you put a 50 in, you're going to say 0.0002x cubed plus 10x. You'll put that 50 in and you'll get $525. Okay, do the math, make sure I got it right. And then when you put 51 in, you're going to get $536.53. So your actual going from 50 to 51, this is just an average rate of change. Delta means change. So your actual is 536.53 minus 525 over 51 minus 50, which is $11.53 per unit. And that's because when you're going from 50 to 51, we've got that discrete graph and not the continuous graph. So this is your marginal profit, $11.50 per unit, and the actual profit to go from 51 to 50 would be $11.53 per unit. So if I had sold 50 units and then I go to 51 units, I'm going to have an additional $11.53 in profit. That's basically what that means. That's your actual, but your marginal profit at 50, exactly 50, is $11.50 per unit. So that's an example of marginal profit. Demand function and a revenue function. Your demand function models the number of units that consumers are willing to purchase at a given price. Your revenue function relates the price per unit and the quantity demanded. So we're going to have, for our demand function, this is a lowercase p is equal to, that's your demand, f of x. Lowercase p, that's your demand. So that'll be your demand function. Lowercase p is your demand function, which is your price per unit. Your price per unit. Your revenue function, capital R, that relates your price per unit and the quantity demanded or sold. So your revenue is equal to the number of units sold, times the price per unit, lowercase p, the price per unit. Now we also call that price per unit demand. So that's the price per unit that people are willing to pay. A business sells 2,000 items per month at a price of $10 each. It's estimated that monthly sales will increase 250 units for each 25-cent reduction in price. Use this information to find the demand function and total revenue function. So let's look at this. Our number of units is 2,000 per month, plus it's going to increase 250 units for each 25-cent reduction in price. So 250 per 25-cent reduction in price. And the price is $10 each minus your demand. 10 minus your demand. Now I'm going to simplify. X equals 2,000 plus 250 divided by 1/4 is 1,000 times 10 minus p. X equals 12,000 minus 1,000 p, because 1,000 times 10 is 10,000. 10,000 plus 2,000 is 12,000 minus 1,000 p. If I solve for p, p is going to equal, let's solve for p, so I'll subtract 12,000 and then divide by negative 1,000. So I'll get 12 minus x over 1,000. So go ahead and try that. Solve for p and make sure that you get what I got. So now revenue is equal to x times p. So revenue is equal to x times 12 minus x over 1,000, which is equal to 12x minus x squared over 1,000. And that's your revenue function. So our revenue function, I'll highlight this. Our revenue function is that value right there, and our demand function is our price, and our demand function is that value right there. P equals 12 minus x over 1,000. Now, if you think about this, we could think about this as ordered pairs. This right here is your slope. So that's your slope. Because your demand function is just a linear equation. So your slope is 250 every 25 cents. So that's your slope right here. So that's orange, right? And then you've got your price, your X, right? So you've got your price minus your $10. So it's $10 each. So what's your difference in your price? Well, your difference in your price would be, it starts at $10, but then it's going to lose 25 cents for every 250 units, right? So it's going to lose a value. So this is the value it's losing. So it loses, right? It's going to lose 250 divided by 1/4. And you start with your 2,000 items. So let's see, this is items. So this is a number of items. And then 250 divided by your money. So you've got units per price. So that means this is price, so that when you multiply that through, you're going to end up with units. So that's going to be units. And then this is also price. So when you multiply that through, you're going to get units again. So this is units, this is units. So you end up with X equals units minus units, and then you've got your price. And then when you solve for your price is all going to be dependent upon your 12,000 minus 1,000 P. I don't know. I think I'm trying to explain it right. I think that this is the most challenging part to come up with right here. So try and mull over that, and I'll try and come up with another video for those of you who really are stuck on that. I'll try to come up with another video to show you exactly where that's coming from. And it's I just don't have a lot of room right here, so I will come back up with that. Okay. Maybe I'll be able to do it right here, and maybe then you'll be able to go back to the next one. Okay, we have a fast food restaurant, or go back to the previous one. A fast food restaurant has determined that the monthly demand for its hamburgers is given by, and this is just given to us, P is equal to 60,000 minus X all over 20,000. Okay, so that's just given information, I just didn't type it in. Find the increase in revenue per hamburger for monthly sales of 20,000 hamburgers. In other words, find the marginal revenue when X equals 20,000. So marginal revenue, that means our derivative. So dr dx. So before we can do that, we need to figure out what our revenue is. Revenue is X times price. So revenue is equal to X times, and then we've got our price. It's 60,000 minus X all over 20,000. I'm going to multiply this through. So watch what I'm going to do here. I'm going to move this to gray. I'm going to say R equals, I'm going to pull the denominator out. Okay, so I'm going to pull the denominator out, and then I'm going to multiply X through to the numerator. So 60,000 X minus X squared. And now I just have this 1 over 20,000, right? I could distribute it back through. It's probably easier to do that. I think I get 3x minus 1 over 20,000 x squared. It's probably easier to do that. And then we take our our derivative. And notice how I'm just writing the derivative with the prime. This is the very first time I'm doing that. That's the same thing as this. Okay. I've been meaning to do that a little bit sooner. So the derivative of 3x is 3, and then the derivative of the next term is 2 over 20,000 x. And now we need to evaluate this when x is 20,000. So I'm going to take that 20,000, put it in for x, and all of this work, dr dx, is equal to 3 minus 2 over 20,000 times 20,000. Look, this is funny, right? Well, 20,000 over 20,000 cancels out. 3 minus 2 is 1. So it's $1 per unit. So the marginal revenue is equal to $1 per unit. Now this, you can use the same equation. Actually, I give you a different equation here, but we're not going to do that. But you can use the same equation and find at 24,000 and then at 30,000 if you want the extra practice. But you would honestly, you've already got the derivative, so doing that extra practice is just doing arithmetic work, and I'm not sure that arithmetic work is really all that fantastic. So not at this level. We're ready to do more derivatives. So what I'm going to do is I'm going to come back in the other video and I'm going to explain that business with the 2,000 items, because I am sure that I stumped some of you, and it's a simple linear equation and I'm with your slope. So I'm going to come back and I'm going to explain that, how I got that, so that you feel a little bit more comfortable with how you would do that on your own.